So for this video, we will be discussing the chain rule. Okay, so but before we introduce the rules for the chain rule, so let's have a situation first. So say for example, we have a given that y is equal to, y is a function of x. Okay, so sometimes when we are given with y as a function of x, it is often convenient to think of y as a function of an auxiliary variable u, where u in turn is a function of x. Okay, so say for example, so we have y is equal to x squared plus 2x minus 5, then raised to 3 halves. Okay, so introducing an auxiliary variable u, so we let u as x squared plus 2x minus 5. Okay, so then y becomes a function of u in the form of y is equal to u raised to 3 halves. Okay, so in taking its derivative, as you can see, our function is expressed as y as a function of u. So therefore, when we take the derivative, what we can actually get is, from here is the derivative of y with respect to u, right? So using the power formula, that would be 3 halves x raised to 3 halves minus 1, so that is x raised to, that is u, no, so u raised to 1 half. So let me change that. Okay, so u raised to 1 half. So but what if we are asked to solve for the derivative of y with respect to x? Okay, so as you can see, we have changed the variable from x to u, no? So therefore, what we get is dy over du. Dy over du. Okay, so what if we are asked to solve for dy over dx? So that is where the chain rule will enter. Okay, so if we have an auxiliary variable u, okay, so to solve for the derivative of y with respect to u, or with respect to x, so this is now the chain rule. So if we have dy, we want to solve for dy over dx. Okay, so that will be equal to dy over du multiplied by du over dx. Okay, so in our previous example, so we have here, okay, so we have dy over du. Okay, so to solve for dy over dx, okay, so we need to multiply dy over du by the derivative of u with respect to x. Okay, so we have here our u. So from here, we can get du over dx. Okay, so here, so we have du over dx. So du over dx is equal to, so just derive u with respect to x, so derivative of x squared, that is 2x. Derivative of 2x is 2. Okay, then the derivative of negative 5 is 0. Okay, so therefore, our dy over dx is equal to, dy over du is this, so 3 halves of u raised to 1 half, no? So since our u is equal to x squared plus 2x minus 5, okay, so 3 halves, our u is, again, we let our u as x squared plus 2x, x squared plus 2x minus 5 raised to 1 half, okay, multiplied by, so this is dy over du multiplied by du over dx. So that is 2x plus 2. Okay, so therefore our derivative is dy over dx is equal to, so we can actually factor out 2 in here. So you have 3 over 2 multiplied by, so factoring out 2, so times 2 times, so writing this, factoring out 2, so what will remain is x plus 1. And then this x squared plus 2x minus 5. Okay, so simplifying, so, oh sorry, raised to 1/2. So simplifying, our dy over dx is equal to 3 times x plus 1 times x squared plus 2x minus 5 raised to 1/2. Okay? Okay, so that is how to use the chain rule. Okay, so we have this. So first, our first chain rule. Okay, so that is getting the derivative whenever we have an auxiliary variable. Okay, so the other rules we also have. So this is rule number 1. So the second rule, so we can also say that dy over dx is equal to dy over du over dx over du. Okay, as long as dx over du is not equal to 0. Okay, and another one, dy over dx is also equal to 1 over dx over dy. Okay, as long again as our denominator dx over dy is not equal to 0. Okay, so those are the chain rules. No, so remember it. So the other two, no, so the chain rule 2 and 3, so we can use that on our next lessons, so please remember it. But for the first chain rule, so this one, okay, so we can use that immediately in our next topic, which is called the general power formula. Okay, so for the general power formula, it's like the power of x formula, but it is general, no? So all functions of x. So if we have a function y is equal to u raised to n, okay, so the derivative of y with respect to u obviously is n, okay, n u raised to n minus 1. Okay, so but what if we want to derive y with respect to x? So from the chain rule, so dy over dx is equal to dy over du multiplied by du over dx. Okay, so since we multiply dy over du by du over dx, no, so we the du cancels out, so what will remain is dy over dx. Okay, so this is from the chain rule. So since dy over du is equal to this, no? So therefore, the derivative of y with respect to x is equal to, so dy over du is n u raised to n minus 1 times du over dx. Okay, so from there, we can get the general power formula. So since y is equal to u raised to n, then the derivative with respect to x of u raised to n is equal to n u raised to n minus 1 multiplied by du over dx. Okay? Okay, so for our first example on applying the general power formula, so find dy over dx for y is equal to 4 over 1 plus 3x squared cubed. Okay, so first to apply the general power formula, so let's recall again the general power formula. General power formula, so we have the derivative with respect to x of u raised to n is equal to n so n multiplied by u raised to n minus 1 times du over dx. So let's get the transform the function into this form, no? So u raised to n, so this will become we have y is equal to 4 times 1 plus 3x squared raised to negative 3. Okay, so deriving y with respect to x, so dy over dx is the derivative with respect to x of 4 times 1 plus 3 x squared raised to negative 3. Okay, so since we have here a constant, so we can take that out. No, so write it. So 4 times the derivative with respect to x of 1 plus 3x squared raised to negative 3. Okay, so here we will follow the general power formula. So here our u is, we can say that's 1 plus 3x squared, okay, and our n is equal to negative 3. Okay, so in applying the general formula, so imagine that this is our u, so the 1 plus 3x squared, okay, and then apply the general power formula, so it will become 4 multiplied by, so following the formula, so the derivative of this is n u raised to n minus 1 times du over dx. So our n is negative 3. Okay, our u is 1 plus 3x squared. Okay, and then raised to n minus 1, so that is negative 3 minus 1 multiplied by du over dx. So the derivative of u with respect to x, so the derivative of u, no, so the derivative of 1 plus 3x squared, so that is 0 plus, so this will become 3 times 2x, so that is 6x. Okay, so multiplying, so 4 times negative 3 times 6, so that is 12 times 6, that is negative 72, I think. So negative 72x times 1 plus 3x squared raised to negative 4. Okay, or dy over dx is equal to, so if you write that in fractional form, so it will become negative 72x over 1 plus 3x squared raised to the power of 4. Okay, so for our next example, so example 2, okay, so for our next example, so find dy over dx given that y is equal to x cubed multiplied by x squared minus a squared raised to 1 half, where a is a constant. Okay, so for this problem, so we will be using, aside from the general power formula, so we will be using the product rule to derive this. Okay, so where this will be our u and then this will be our v. So derivative of a product, we have u times dv over dx plus v times du over dx. Okay, so to start, so we have dy over dx is equal to, so our first factor, x cubed multiplied by the derivative of the second factor, so d over dx of x squared minus a squared raised to 1 half plus the second factor, which is x squared minus a squared raised to 1 half multiplied by the derivative with respect to x of the first factor, which is x cubed. Okay, so performing the derivatives, performing differentiation, so we have x cubed multiplied by, so applying here the general power formula, so where x squared minus a squared is our u and our n is 1 half, so we will have n u raised to n minus 1 times du over dx. So our n is 1 half multiplied by u, which is x squared minus a squared raised to 1 half minus 1 multiplied by du over dx. So multiply it by the derivative of this. No? So derivative of x squared minus a squared, that is 2x. Okay, since a is a constant. Okay, plus we have copy x squared minus a squared raised to 1 half multiplied by the derivative of x cubed, so that is 3x squared. Okay, so simplifying, so we have here x squared times 1 half times x squared minus a squared raised to 1 half minus 1 times 2x, so we can cancel 2, right? And then multiplying x times x cubed, so that is x to the power of 4. And then we have x squared minus a squared raised to negative 1 half. Okay, plus x squared minus a squared raised to 1 half, okay, multiplied by 3x squared, sorry. So let me just rewrite that. So transfer the 3x squared here in front, so we have x to the 4th times x squared minus a squared raised to negative 1 half plus 3x squared x squared minus a squared raised to 1 half. Okay, so this may qualify as your final answer. Okay, but if you want your answers to be more compact, then you can factor, no? So factor your answers. So for this answer, so our greatest common factor, so we have, sorry, this is x, yes, this is x squared. So in this, for x, the greatest common factor is x squared, and then here the x squared minus a squared, and x squared minus a squared here. So if you don't want two terms, no, so you can still combine them. So we can factor out x squared minus a squared raised to negative 1 half. Okay, so our factor, greatest common factor is, for x we have x squared. Okay, and then we can factor out x squared minus a squared raised to negative 1 half. Okay, so what will remain in the first term, if we factor this out, so if we factor out x squared and x squared minus a squared raised to 1 half, so what will remain in the first term here is factoring out x squared and this, so what will remain here is x squared. Okay, so just remember that factoring is the same as division. Okay, so this x to the fourth times x squared minus a squared raised to negative 1 half divided by x squared times x squared minus a squared raised to negative 1 half. So what will remain is x squared. Okay, plus factoring out again this from the second term. Okay, so 3x squared times a squared minus times x squared minus a squared raised to 1 half divided by x squared times x squared minus a squared raised to 1 half. So what will remain is, we can cancel out x squared, so what will remain for the numerical coefficient is 3, and then x squared minus a squared raised to 1 half divided by x squared minus a squared raised to negative 1 half. So that will become x squared minus a squared raised to 1 half minus negative 1 half. Okay, so 1 half minus negative 1 half is equal to 1 half plus 1 half. So therefore, it's x squared minus a squared raised to 1. Okay, so simplifying, so we will have x squared times x squared minus a squared raised to negative 1 half, so multiplied by, so this will become x squared plus 3x squared minus 3a squared. Okay, so simplifying, no, so this will become 4x squared minus 3a squared, and then rearranging so that it looks good. So dy over dx is equal to x squared times, write this first because it has no exponent, so 4x squared minus 3a squared times x squared minus a squared raised to negative 1 half. Okay, so this is our factored form, no, from here. Okay, but this will qualify as your answer already. Okay, but if you want to your answer to look good, no, and also depending in the choices in the examination, so if the answer in your examination is in factored form, then you have no choice but to factor it also, so that you can compare which is the right answer. Okay, so for our third example, so we have this one. So derive with respect to y, x is equal to y squared minus 1 squared over y squared plus 1. So for this problem, obviously we will be using the quotient rule. Okay, so let's recall first the quotient rule. Okay, so we have this one. So the derivative of u over v with respect to x is equal to v du over dx minus u dv over dx over v squared. Okay, so that means denominator multiplied by the derivative of the numerator minus numerator divided by the derivative of the denominator over the denominator squared. Okay, so for this problem, so our u obviously here is y squared minus 1 squared, and our v is y squared plus 1. So now to derive y with respect to x, to derive x with respect to y, so we will have, so the denominator, which is y squared plus 1 multiplied by the derivative with respect to y of the numerator, which is y squared minus 1 squared, okay, minus the numerator y squared minus 1 squared multiplied by the derivative of the denominator, so d over dy of the denominator, which is y squared plus 1 over the denominator squared, so y squared plus 1 squared. Okay, so deriving, so we will have here, so copy y squared plus 1 multiplied by this. So here we can use the general power formula, okay, where our u is y squared minus 1 and our n is 2. So following the general power formula, so recall the general power formula, so the derivative with respect to x of u raised to n is equal to n u raised to n minus 1 times du over dx. Okay, so our n is positive 2. Okay, and then our u is y squared minus 1 raised to 2 minus 1. Okay, and then multiplied by du over dx, so the derivative of this with respect to y. So derivative of y squared is 2y, okay, minus constant, so 0, so times 2y, so minus, so copy y squared minus 1 squared, and then multiply with the derivative of y squared plus 1. So derivative of y squared with respect to y is 2y. Okay, and then we have derivative of constant, so 0, so 0 over y squared plus 1 squared. Okay, so next is we simplify, so we will have so 2y times 2, so that is 4y times, we have y squared plus 1 and y squared minus 1 minus, so here we will have 2y times y squared minus 1 squared over y squared plus 1 squared. Okay, so next is we can factor the numerator. So factoring the numerator, we will have greatest common factor is, okay, so factoring the numerator, we have the greatest common factor. So for the numerical coefficients, the greatest common factor is 2. And then we also have a common factor of y and a common factor of y squared minus 1. Okay, so therefore the greatest common factor is 2, y, and y squared minus 1. Okay, so if we factor this, no, so what will remain in the first term of the numerator is so 4 divided by 2, so we have 2, y divided by y, 1, and then y squared plus 1 times y squared minus 1 divided by y squared minus 1. So what will remain is y squared plus 1 minus, so if we factor 2y and y squared minus 1 from here, so what will remain is y squared minus 1. Okay, over y squared plus 1 squared. Okay, so therefore, simplifying, so what will remain is 2y times y squared minus 1 times, so this will become 2y squared plus 2 minus, we have y squared plus 1 over y squared plus 1 squared. Okay, so simplifying that, this one, so we will have 2y times y squared minus 1 times 2y squared minus y squared, so that is y squared, and 2 plus 1, that is plus 3. Okay, over y squared plus 1 squared, so that is our dx over dy.